Hi, we are from Group 7, from class DAM 12803, Basic Electrical and Electronics Section 2. We are going to presenting our simple circuit project that is power failure circuit, power failure alarm circuit.
Assalamualaikum and good morning everyone. Today we will present our project about power failure alarm system. Power failure is a problem that can happen unexpectedly in our daily life. It may affect electrical equipment, interrupt important activities and cause inconvenience to user. Sometimes user may not realize that a power interruption has occurred, especially when they are away from the equipment. Therefore, a power failure alarm system is useful because it can provide an immediate warning when the main power supply is disconnected. For the subject, we design a simple alarm circuit using basic electronic components such as capacitor, transistor, resistor, and buzzer. Each component has its own function to ensure the circuit work properly. The capacitor is used to store electrical energy when the power supply is available. When a power failure happen, the stored energy is released and used to active the buzzer. The buzzer will produce a sound to inform user that a power interruption has occurred. This project is simple, low cost, and help us understand how electronic component can be used in real life application. Next, I will explain the theory of the power failure alarm circuit. This circuit work based on the concept of energy storage and switching during normal operation. The power supply provide energy to the circuit and the capacitor start charging to store electrical energy. At this stage, the circuit remain in standby mode because the power supply is still available. The transistor does not activate the buzzer, so no warning sound is produced. When the main power supply is disconnected, the capacitor begin to release its stored energy. This energy allow the circuit to continue operating temporarily after the power failure occurs. The transistor act as a switch that control the flow of current to the buzzer. When the transistor is activated, the current flow through the buzzer and produce a warning sound. The resistor help to control the current and protect the circuit component. The capacitor value also affect how long the buzzer can operate after the power supply is removed. Overall, the circuit show how basic electronic component can work together to detect power failure and provide an alert signal to user.
Hi, my name is Muhammad Fadal Hakim Rizal, number matric AA250056. Next, I will present about the literature review of our project. A power failure alarm system is designed to provide a warning whenever the main power supply is interrupted. From previous studies, many modern systems use IoT, Internet of Things, technology for real-time monitoring and mobile notifications. Some systems also use artificial intelligence (AI) to improve fault detection and increase reliability. For our project, we apply three main engineering principles. First, the capacitor stores energy and releases it when a power outage occurs. Second, the transistor acts as a switch to control the buzzer. Third, the diode prevents reverse current flow and protects the circuit. Overall, these principles enable our circuit to detect power failures effectively while keeping the design simple and low cost. These slides show the result of our power failure alarm circuit. During normal operation, the 12-volt power supply is connected and capacitor C1 charges while storing electrical energy. The transistor remains in its normal state, so the buzzer stays off. When a power failure occurs, the power supply is disconnected. The energy stored in the capacitor C1 discharges through the transistor circuit, causing the transistor to switch on and activate the buzzer. This alerts the users that a power interruption has occurred. and the simulation shows that the circuit responds immediately when power is lost. The alarm duration depends on the value of capacitor C1 because a larger capacitor stores more energy. Overall, the circuit is simple, reliable and effective for detecting power failures. Next, I will explain the significance of the calculations for our power failure alarm circuit. The first result is the RC time constant, which is approximately 47 seconds. This value indicates how long the capacitor can continue supplying energy after the main power source is disconnected. In practical terms, it provides enough time for the circuit to respond to a power failure and activate the alarm. The second result is the energy stored in the capacitor, which is approximately 0.338 joules. This stored energy acts as a temporary backup power source. When the power outage occurs, the capacitor releases this energy to the buzzer, allowing the alarm to sound even though the main supply is no longer available. These results show that the capacitor plays a crucial role in ensuring the reliability of the system. It provides short-term backup power and helps the circuit detect and alert users to a power failure immediately. Overall, the calculations confirm that the power failure alarm circuit can operate effectively during a power interruption and successfully perform its intended function of providing an audible warning.
Conclude, the power failure alarm circuit was successfully designed to detect power interruptions and activate a buzzer as an alert when the main power supply is disconnected. Based on the calculations, the circuit has a time constant of 47 seconds and the capacitor is able to store approximately 0.338 joules of electrical energy. This stored energy allows the buzzer to operate for a short period after a power failure occurs. Overall, this project demonstrates that basic electronic components such as capacitors, transistors, and buzzers can be used to create a simple, low-cost, and effective power failure detection system.